So today I will be recording this video to tell you how I wrote my code to determine some changing forces acting on a system, specifically the system of the Earth, a rocket, and the Moon, and then translating that system into a computational model, and this computational model is VPython, and then I will be using that model to determine the future motion, and this future motion is specific to when the rocket can actually crash into the Moon. And so in order to do that, I looked at the problem statement. And in that problem statement, you ask me to determine the direction and duration of the rocket burns, and the fact that I only have 165 seconds of thrust, and then the rest of it will just have to be forces acting upon the rocket that will carry it to the Moon. So I will be just doing 2A, and I'll be taking you through my code. So the first thing I did was set up a couple of constants that are going to be really important to me. My gravitational constant, and then I set up a time, and then my dt. So then I can start updating my motion once I establish the forces acting on my rocket. And then after that, I set up a couple of the objects. So the three objects that we'll be looking at in the system are the Earth, the Moon, and my rocket. So I'm going to define my origin as the Earth, and then everything surrounding that will be in respect to the origin. So my Moon is going to be this distance away from the Earth, and then my rocket is actually going to be sitting on the top of my Earth when it is ejected. And a couple of other things that were given to me, or that I found that are just values, were the radius of the Earth, the mass of the Earth, the vector of the velocity of the Moon, which is in the negative z direction, the mass of the Moon, and the momentum of the Moon. And then I looked at the rocket, which again is sitting on the surface of the Earth. I looked at the radius of that, as well as the mass of that, and the momentum of the rocket. And the momentum is actually something that I found, or I determined. And so to start my while loop, I had to first establish the three main forces that I'm going to be using. Since we are not on the surface of the Earth, we're not going to be using any kind of 9.8 acceleration, gravitational acceleration. Instead, I'm going to be using the extended version of gravity. And there are three different forces of gravity that I had to account for. The gravitational force of the Earth on the aircraft, the gravitational force of the Moon on the aircraft, and the gravitational force of the Earth on the Moon, which actually swings it into orbit. So these three forces were calculated using the gravitational potential energy equations, and then they were set to equal my F net. And before I go into my F net and updating my position, I just want to make it very clear that my time for the rocket to be exerting any kind of force was less than 165 seconds, which was the time that my thruster could have gone for. So the next thing that I did was update the position of my rocket, and since my Moon was also moving, I had to update the position of my Moon. So in order to update the position of both of these objects, I took the initial momentum and then I added that to the net force. In the case of the rocket, it was the force of the Earth on the rocket, the Moon on the rocket, and the thrust of the rocket, and then I multiplied that by dt. In the case of the Moon, I was just looking at the force of the force of the Earth on the Moon and multiplying that by dt. And then to update both of them, I used the same method, in which the future position was equal to our initial position plus our momentum over mass times dt. And then after that, I updated my time, and then as soon as I put in an if statement just so as soon as the Moon and the rocket collide, my loop would break. So let's just see what that does, and hopefully it'll run. Alright, so it's a little hard to see right now, but I will show you that one more time. So we actually have the rocket coming towards the Moon is moving, and then they collide. And so again, that is only for 165 seconds of the rocket moving, and then the moon and the rocket collide. Thank you so much.